Hello everyone in CSC-121, Graphical Python Programming. This is the last lecture of the semester. I hope you're excited about that, or as excited about that as I am. We have been through a lot of material in this class, and a lot of it you won't find anywhere else. So we have, in this module, we've been through a general threading and multiprocessing lecture. We've also been through a lecture on using the QThread pool, which we said the Qt5 QThread pool was useful if you had something or things that you needed to just kind of spin off and let them do their thing and run until they finished. If you need to have threads that can send signals out, what we call emit signals, just like a dialog form's buttons do, that's a very powerful thing to be able to send information back and forth between threads and your GUI for your program. That's extremely difficult to do in a lot of implementations, and probably would not be teaching it in this class if it weren't for this technique that I'm fixing to show you. This technique is very powerful because you can inherit the QObject class from Qt, and QObjects have the ability to emit signals, just like a button emits a signal when you click it. And so we can emit things from our threads and have our GUI pick those up, just like we connect to the clicked event of a button. We can connect the signals that we create for our threads back to our GUI, and that makes life so much easier. So much easier. So if you have something that needs to communicate back and forth a lot with your GUI, then this is the technique if you're using Qt. It eliminates having to create a queue. It eliminates, if you weren't going to use a queue, you'd have to use a pipe. And either one of those is a lot more complex than what we're doing here. So let's get started. I'm going to click into that folder. You saw where I was, but I'll go back just in case. I'm in Module 7, and right here's the lecture using Qt5's QThread and QObject move to thread. So when we're in here, I wanted to show you how a program would function that had to download a bunch of images. And so we'll set this program up to download 20 images over the internet. And right now, it's just going to do it in line with no threading. So what we call a single thread. So I'm going to run this version of the program. Now, I've given this to you out there in Blackboard. I'm not going to create this because I'm going to focus on creating the multi-threaded version, but you've got the code out there. I can't imagine why you would want to do what's being demonstrated here, the reason I did it was so you could see the difference between doing it, to see how much difference multi-threading something that's downloading a bunch of stuff from the internet, so you could see how much difference that makes. So this is the GUI that's being used, and you can see the single thread version of this. I've already downloaded it, so right here it is, get URLs single thread. And let me talk about one thing here that you may need to do if you were going to run this program, and you should probably get this package anyway, because there's probably another program that you would need that uses this request package. So to get the request package, which adds things to Python where you can download just like you would do with a web browser, you just go to Tools and Manage Packages, and then you can search for request. And when you search, you'll see that I've already got it installed, but you would have a button here to install request to your Tawny program, and you can see summary Python HTTP for humans. So we'll consider ourselves humans and download this package. So alright, so once you've got that package downloaded, then we can run this program. And remember, this is doing it all single thread, one at a time, so it's going to block our GUI while it's running. So here we go. I'm going to click run. Okay, and you can see that it downloaded a bunch of files. It downloaded 40 files in 2.5 seconds. 2.5 seconds to download 40 files. And so it was just going out to realpython.org and downloading the dice image over and over. So that's single threaded. I'm on a pretty fast double internet connection, so you can see I got them all down in 2.5 seconds. So that's single threaded. And just to give you a preview, this program implements just one thing. It's got a class for the form like we're accustomed to doing. And here it is the code to download the sites. You can see that it's got a function to download all sites, and this function that downloads all sites is actually calling another function to download a site. So this function to download every single one of those sites is calling this function to download an individual site. So the GUI, as I'm sure you may have noticed, the GUI has not much on it. It's got a push button and it's got a plain text edit, which is right here, a plain text edit. I love the plain text edit and the other version of the text edit that does rich text. So the reason I like these so much is, if you recall our printing material where we had to print something, this you can implement a print with about 2 lines of code versus something like the list box where you had to write your own paint event and capture the pix map and all. A plain text edit is 2 lines of code to print from it. So or a rich text edit, this one here, both of those real easy to print from, just incredibly easy to print from. So alright, so we've got a run method that's collected to the button, and you can see what it does is it creates a list of 20 sites. So this list has got the site that it's going to in HTTP, and it's going to download that 20 times. It's capturing the start time, it's downloading all the sites, and then it's capturing the end time. And each time we download something, it's doing an insert plain text out there so that we can see what was read. And if you go back and run this again, you can see there's the insert plain text stuff coming out. When it finally gets to the end, it writes this line right here, downloaded 40 in 1.7 seconds. Okay, so that's coming from doing this work. So we've got that going on, and we can then go implement this as a threaded program. And I hope you can see why we would pick threading for this. If you remember from the general lecture, if you're doing something that your computer has to do a lot of waiting, then threading is a great choice for that. If you're copying a file, threading is a great choice for that. If you're sending emails, threading is a good choice for that. But if you were doing something that was CPU intensive, we probably wouldn't be threading it. We'd probably be wanting to multi-process that. And you can go back and watch that lecture again if you don't know what I'm talking about when I'm talking about the difference and why you would want to multi-process as opposed to thread something. Okay? So let's get started creating this program from scratch. I'll create myself a new window here, and let me go out there and open up that material in Module 7. I've downloaded the GUI template already, the GUI template, so that I can use that as a starting point for this. And we're going to need to add the imports for the request, and we'll need to add some other imports for the Qt things that we're doing. So let's go ahead and get the request out of the way here from, let's see, not from, just import request. That's for our web access stuff. And then we'll import time so that we can get the start time and the end time. And then we're going to use some more things from Qt, obviously. You remember I said QObject and some other things. So from PyQt5.QtCore import, and we are going to need the QObject. Everything in Qt, unless you everything in the GUI pretty much inherits QObject. So if we inherit QObject, then we get something that can emit signals, and that's an important thing to be able to do. QThread lets us actually create threads. We also, since we're going to create some signals, we need to import PyQt signal, and we've got Qt imported, so we're good to go with our imports. So Let's, as I mentioned to you in the previous lecture, using the QThread pool, anytime you're threading something out, it's a much better choice to implement a class, and you pretty much have to do this with Qt. It doesn't give you a choice. Some of the Python ways of threading, you don't have to create an object or a class to do it, but I still would encourage you, even if you're doing that, to create a class so that you have an instance. Each thread or each process is its own instance, so that you're not dealing with shared variables in functions and all that other stuff. So class, and then we will create one that's called get URLs, and we'll inherit this Q object right here. I'll just go ahead and paste it. We're going to inherit Q object. Okay, first off, we're going to need to set up our signal so that we can emit a signal when our thread is finished. So we can tie that signal to something. So finished equals PyQt signal. Now, you need to understand right here, when we're setting up this signal, if you're going to move something to a thread, the only way that Qt knows that that thread is finished is when you emit this signal. If you don't emit this signal, it's going to stay out there in an active state forever, which would not be a good thing. Okay, so if you're going to implement this QThread, you have to emit a finished signal. Next, I'm going to do another signal, send text signal, and that's going to be another PyQt signal. Now, let me explain what we know. This is required. I just told you this is required for thread to finish. This one, we're going to use this to emit text to a plain text edit. That's pretty cool that we could even think about doing that. We're going to have this object that's sitting out there running, and as it does stuff, it can emit a signal to a plain text edit on a GUI that's completely different from this thread. So, and since I'm wanting to emit something, I'll tell it that I'm emitting a string in there. So we just created our own signal that's going to emit a string back to our GUI. Okay, let's do the constructor for this. This is a constructor for our class. And it's going to take one parameter in, that's the list that has all the sites in it. So we need to call the super so that we can run the constructor in the base class, so that all the stuff that a Q object requires gets built. So I've got that done, and then let's capture this sites and save it to our object so that we have it. Self dot we'll make that a private. We'll make that a private class variable. Okay, so we've got that saved. That's the only two things that we need to do in there. Now let's create our method to download all the sites. Download all sites. Has to inherit self, or get self, sorry, as a parameter. Start time, so that we can keep track of when we started, equals. Okay, we got our start time captured. Now here's where we're going to use the request object. Creating a session object. So that's opening up an HTTP session. Okay. For URL in self.sites. Okay. So this is our sites list that we saved. It was there when we called our get URLs. Okay, we saved it right here. Now we're rolling through it with this loop. Each time through the loop, it's going to get another URL to download. Self.download. Self.download underscore site. That's a method that we haven't written yet. Okay. Once we're done with that little for loop, duration equals time dot time minus start time. So once that runs, we've got how long it took to download all these sites, however many it was that we were downloading, which I think we're downloading about 20 in each of these. So now let's emit a signal. We said that we set this signal up here that could emit a string. So let's emit a signal here. Syntax signal.emit. Will you do a format string? Okay. So let's build our format string here. Okay, this is going to get us how many sites we downloaded, because we're getting the length of that list in whatever the duration was. Okay, and that's the end of it. Love those F strings. Wish they had been out years ago. Okay, now since we're doing threading, I know you've seen me use application process events, but in the other lecture that I did here when we were doing threading, you may remember we did another way, Q application .send posted events. Okay, so and then let's emit our finished signal. This is what's going to actually shut the thread down. Self.finished.emit. So when we emit that finished, that's the end of our thread right now. When we emit that, it's over. Okay? So now let's write our method here. You remember this method is calling download site, so we need to write our download site method. Okay. Okay, and download site has got to take in a couple more things than just self. It needs to take in the URL, and it also needs a session. It's got to have a HTTP session in order for this to work. Okay, with session.get URL. This is what's actually going to download that. Okay, so self.send text signal.emit. Now here we're still emitting something to the plain text widget that's on our GUI. This one was emitting when all the sites were downloaded. This is going to emit each time we download a site, so we're getting more information before we actually finish downloading, so we can see all the individual things as they come down. Okay, so here we'll say red, and then we'll put some more placeholders out there. Response.content. We're getting the length of that, so that's going to populate that little placeholder. From this placeholder, we'll get you the URL that we're operating on that came in right here. Okay, and then we'll put a \n, and that's the end of that. Okay, so response.content, there's where the response is. Okay, here we're getting the length of it. So this will say read however much it read from that URL, which is right there. Okay, so we need to then do this send posted events because we're threaded and we want it to happen, pretty much right away. We want it to show up in that plain text edit. And just for good measure, so that we don't hang anything up or slow the system down, I'll go ahead and add a process events in there as well. Okay, so that's the end of our class to download all these URLs. Okay, so now that we've got that done, we need to connect up our one solitary push button. There's just one. We also need to connect this to the UI file. Let's see what that UI file is called. Get URLs threading. Okay, so get URLs threading.ui. And I need to go ahead and save this as another name, so I'm going to go ahead and copy that and save this as that name. So file, save as, and go up one and up another one. Move to thread lecture. Right here's where I want to be. Get URLs threading.py. Save it. Okay, so we've got that saved. Let's connect up our push button. Self.ui.push button. And what was it named? Push button run. Push button run. self.run method sounds as good as any. Okay, so we need to write our run method now. Okay, this is what's gonna kick off our program. Let's go ahead and do this. I normally like to test the program a little bit before now. Self.start time equals time.time. I'm gonna capture the start time here when we first click our run button so that we have the overall time, because we are gonna create 2 different threads to each download these sites. So we're going to create 2 of these threads instead of just having one that was run in the thread with the event loop. We're going to spin 2 of these things out to download those sites. So that's why I'm capturing the start time. And I'm going to go ahead and save this and then just run it just to make sure the GUI is hooked up. And it looks like it is. We've got a run button, and that's all right now. So you can see all it did when I clicked run was this one line, and then it basically came back to the GUI. So we're here in the event loop. We do have an exit button. So all right, so we need to write some more code here. Let's create our list of sites, and actually I've still got this one open, so I think in here I can just save myself some time and copy that and add that here. Okay. Let's get my indentation right. So this, since we were doing 20 in the single thread, I'm going to change this to 10 because we're doing 20. We're still doing 20, but we're going to spin these out into 2 threads. So that means that in order to get 20 just like we were doing in the single thread, I need to have 10 in each of my 2 threads. So, all right, let's create an object. The object is going to be an instance of our get URLs. So let's create that. And remember, it takes a parameter in that is the sites. Okay, so here we go. Self.obj1. This needs to be part of the main class here. Equals get underscore URLs, and we're going to pass the sites to it. That's our list of sites. So at this point we have created an object, and it's part of our main form class. Okay, so now let's create a thread. Self.obj thread 1 equals QThread. So at that point we've created an instance of our class that we created. We've created a thread. Now what we're going to do next is a very sneaky way of making this work. I haven't seen many people implement this in Python at all. Self.obj1. This is our class that we have created. We're going to take that class, and because we inherited QObject, QObject has a move to thread. And this asks for what we want to move. what thread do we want to move it to, and the thread that we created was self.obj thread 1. This is super cool right here. This takes an object and moves it into a thread. Very powerful to be able to do that. Okay, now we need to connect up our events or our signals. Self.obj1 dot. The first signal that we need is finished. That's what we emit when we're done. Okay, and we're going to connect that to self.obj thread 1 dot quit. So when we emit the finish signal, it's going to emit to a slot on our thread, and the thread will quit. So that's the way we shut this down. Next, we're going to connect up our send text signal. Send text signal was the one we created right here, that we're sending a string, and we'll hook that to our plain text edit. And it's super cool that you can even do that, that you could connect that signal straight to a plain text edit on our GUI dialog. Now we're connecting this to our plain text edit, and it really you could either use self or you could use self.ui because it's actually present both places. Okay, this is the method, or the method of the plain text edit on our dialog form, and it's going to receive that text that we are emitting right here. So whatever we emit from our thread will automatically get popped into the plain text edit. Okay, and we're going to use something called a Qt connection. Because this is queued, we don't know if we've got multiple threads. We don't know whether our plain text edit on our GUI can take this right away, or whether it might be taking something from another thread. And so the fact that it uses a queued connection, if there's more stuff in that than this plain text can take right away, it puts it out there on the queue, and eventually it will make its way to the plain text and show up. Okay, so now we need to connect a start method. If I can type here, self.obj thread 1 dot started dot connect. We're going to connect that to the download all sites method on our obj1. See, our obj1 is right here. That's our class that we created. We're connecting the download all sites method to that. Now, this is the method that starts downloading stuff. So when our thread gets started, it automatically goes up there and it starts doing the stuff in here automatically because we have it hooked here. Okay, so next let's crank it up. Self.obj thread. I misspelled thread up there. Glad I saw that. Thread 1.start, and that actually hits the start button on our thread, and our thread gets cranked up at that point. And so let's just kind of check through this. We've got our get URLs connected there, processing all sites. We've created a thread object. We moved our object to the thread that we created here. We've connected up the object's finish signal to the quit slot on the thread. We've connected up the send text signal to the plain text edit that's on our GUI. This is the plain text edit right here. You can see Q plain text edit. See the name plain text edit. So that's connected up to the insert plain text method. We're using a Qt GUI connection. Okay, we've got the thread started signal is gonna be connected to our objects download all sites, and then we're finally cranking the thread up. And so we want to do exactly the same thing that we just did for thread 2. So I don't have to write all this again. I just, everywhere there's a 1, I need to change it to a 2. So hopefully I won't miss one of the 1s here. So we're going to create an object 2 for our second thread. And there's our second thread. And there's obj2. Move to the thread 2. Our obj2 finished is connected to the thread 2 quit. Our obj2 send text signal is connected to the same plain text edit. So both threads are emitting to the same plain text edit. Even more cool that you can have 2 threads emitting to the same thing. Okay, and then that's the end of that. So we've got that all hooked up. Now, if I didn't put a little while loop in here, we wouldn't be able to get the right time for how long it took to run both these threads and wait for them to finish. Now, if you saw the threading lecture at the start of this module, you saw that there was a join method. When we're using this QThread, we don't really have a join method, so we can't sit here and wait on those threads to finish, but we can write some code of our own to wait, and I can do that with a while loop. While self.obj thread1 is running. If I call this, as long as the thread is running and hasn't emitted a finish signal, okay, as long as that thread is running, this is going to return true. So I can use that to my advantage here in this while loop to keep this loop running as long as our thread 1 and our thread 2 are running. So we'll just stay here in this loop until they are finished, until they're both finished. I'm going to send out any posted events that might be happening, and I'm going to do process events as well, just so that we're sure that our application is being responsive. And then we'll do a time.sleep, and we'll put a really low number in here. This is only going to sleep for 1,000th of a second. So this loop's going to sit here and roll, and it'll stay there in that loop until both of our threads are finished. And then we can do this duration equals time.time to get the finish time, and we'll subtract that from the self.start time. That gets us how long it took, and then we'll send something to our plain text edit here. So we can do that. Self.plain text edit was the name of it. Insert plain text. Okay, so we'll write out an F string there, and this F string will just say how long it took. All, we'll do caps, all sites downloaded in duration. Okay. Okay, so at that point, I think we're done with this program. Let's just check our code right here. Our F string looks good. It's got this curved brackets around duration. We're creating duration there. So it looks like we have something here that we can run. So I'll save it. And just as a review here, here's this one, single threaded, that's downloading those 20 sites. Let's run it again and see how long it takes. Okay, here it is. Run. Single thread, it took 1.4365 seconds. Okay, 1.4365 seconds. Okay, now here's our threaded one. Let's see if it runs. We may have to debug a little bit, but we'll try it. Okay, here's our multi-threaded one. 9 seconds. 9 seconds. Okay, so went by pretty fast. It actually went by so fast that I think it caught our loop, and it was not able to write something out before our loop finished, because we need to go back and maybe add a little bit of a delay right here while we're waiting on these threads to finish. Maybe we'll make that delay half a second and see if that will give this while loop enough time to pick that up. So we'll start that again and run it. Well, that was fast. And it looks like we got 20 and 20. So we were doing 20 total. Well, I think we need to back this out a little bit, because we're downloading 20 twice and we're still finishing in a faster time than what what we were doing with the single thread. So we're doing twice as many sites in the same amount of time. So let's try this. 5. Run it again. Okay. And all sites were downloaded in 1 second. It's running so fast that my delay here is not long enough. Let's make it 9/10 of a second and see if we can get this delay. Bam. I think that delay is actually adding 9/10 of a second. But this wait right here is always a problem because these things here are finishing so fast that they're actually finishing before my wait can even process one loop. So if we were on a slower internet connection, it would be a better demonstration, or we can actually bump this number back up again and do twice as many as we were doing before. And you can see that we downloaded all of them. We downloaded all of those sites, looks like in 1.8, doing twice as many as a single thread. So that's the way you can spin 2 threads up and get most of the time, unless your internet is super fast, you can finish doing a lot of work. Let's just crank this up and do something interesting, like we'll download 40 here in this one, and we'll download 80 here in this one, because we're downloading 40 twice here. So we'll download 80 in the single thread, and let's try that. Still downloading. Okay, 6.12 seconds. Okay, 6.12 seconds. Now let's go to this one and do the same thing. .31, so almost twice as fast. And we could spin more threads up than just 2. If we wanted this thing to really book, we could spin up 4 threads and have each thread download 10 sites like that. So each site is downloading 2 things. It's downloading using HTTP, and it's downloading HTTPS. That's why whatever number we put here is really twice as many. So that's the end of this lecture and the end of the lectures for the class. I will do another video that explains the final project that you have to write in this module. It's just a normal project, and about 60% of the project is already done for you. It is a single-threaded project that pings a series of network addresses, and it's already single-threaded. You have to take it and make it multi-threaded. So a network exploration program that you will be writing for the last project in the class. So good luck. This has been a very powerful technique that we've learned. Of course, there's a lot of stuff in this class, from databases to multi-threading to all kinds of GUI stuff that runs on anything that I don't think you'll find anywhere else. So I hope you benefit from this professionally as well as academically. So good luck, everybody, and we will see you around in the ether.